Okay, this is an exercise from section 8.1, Basics of Hypothesis Testing. This is question number 5. This is also can be referred to as 8.1.15. And this is a great example of when we have a two-tailed test. So the test statistic of z equals 2.86 is obtained when testing the claim that the proportion of some population is not equal to 0.135. So in part A, we have to identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. We need to be able to find the p-value, and then we also need to use a significance level of 0.01 to determine if we're going to reject the null hypothesis or if we fail to reject the null hypothesis. So I'm going to go ahead, I've set this up with some scratch paper here. And so the first thing I'm going to do is whenever you're determining the tailed test, what tailed test this is, you have to look at the symbolic form of the claim. So our claim here is that the proportion is not equal to 0.135. So this not equal symbol tells you that this is a two-tailed test. All right? So we know that. Now we have to find what the p-value is. So our p-value, since we're talking about a proportion, and our test statistic, so our test statistic is z equals 2.86, the way we're going to find our p-value here is this is a two-tailed test. So what we want to do, if we think about a normal distribution here, we have one tail here at 2.86, so there's area there, and then we also have a tail down here at negative 2.86, so there's area here too. So what I'm going to do is I'm going to open up my normal calculator, and I'm going to find the area to the right of 2.86, and then I'm going to double it, or I'm going to multiply it by 2. Because the p-value here includes the area to the right of 2.86, but it also includes the area to the left of negative 2.86. So I'm going to open up, I'm going to go back here to StatCrunch, and I'm going to open a normal calculator because we're dealing with a z statistic here. So I'm going to go calculators and normal. And I am going to leave my mean and my standard deviation for a standard normal distribution. But now I'm going to change my inequality to greater than. And I'm going to type in the stated test statistic of 2.86. And when I hit compute here, that's the area to the right of my test statistic. So 0.00211,821. And I should have a calculator. Well, I'm going to go ahead and I'm going to open up my calculator here. I'm getting a little crazy with my screens. So I'm gonna key this into my calculator. So 0.00211. So let's clear out what we have here. 0.00211. So 0.00211,821. Now I probably don't need that many digits, but that's what I'm gonna go with. So I'm gonna multiply that by 2, and that's gonna be my p-value. My 0.00423,642. Now they probably want me to round that. So let's get caught up here. So part A, we already know this is a two-tailed test, so we should get that correct. And we do. And now our p-value to 3 decimal places is going to be 0.004. So let's try that. So 0.004. And we should get that correct as well. And we do. Now, choose the correct conclusion below. So are we going to reject our null hypothesis or fail to reject our null hypothesis? Well, notice that our alpha is 0.01 and our p-value is 0.004. So our p-value is less than alpha. So our p-value is less than alpha. So when the p-value is low, the null must go. So we are going to reject our null hypothesis. But what are we going to say about the evidence? All right, so let's go back here. So we've decided that we are going to reject our null hypothesis. So let's start here. Does the original claim contain the condition of equality? No, it has not equals, right? So we're going to go here. Do you reject the null hypothesis? Yes, we do. When the p is low, the null must go. So we are going to reject the null hypothesis. And so it says here that there is sufficient evidence to support the claim that. So I'm going to go back. So we are going to reject our null hypothesis, and there is sufficient evidence to support the claim that the proportion is not equal to 0.135. I'm going to check that answer, and I get that one right. So that is a walkthrough of, so I've done a video now on a right-tailed test, and I've done a video now on a two-tailed test, and that is how you can conquer, if you will, for question number 5 or 8.1.15 from section 8.1.